and welcome to the ISC 11 Maths tutorial. Mahatma Gandhi says, speed is irrelevant if you are going in the wrong direction. और आइए आपको एक शायर की कुछ लाइन सुनाता हूँ. शायर कहता, ताल्लुक कौन रखता है किसी नाकाम से, लेकिन ताल्लुक कौन रखता है किसी नाकाम से, लेकिन मिले जो कामयाबी सारे रिश्ते बोल पड़ते हैं. मिले जो कामयाबी सारे रिश्ते बोल पड़ते हैं. मेरी खूबी पे रहते हैं यहाँ अहले जुबां खामोश. मेरी खूबी पे रहते हैं यहाँ अहले जुबां खामोश. मेरे ऐबों पे चर्चा हो तो गूंगे बोल पड़ते हैं. मेरे ऐबों पे चर्चा हो तो गूंगे बोल पड़ते हैं. शुक्रिया. थैंक यू. Okay, so today's topic is we are going to learn how to differentiate functions like u upon v. That means we are going to learn how to use quotient formula. We are going to learn how to differentiate such functions u upon v. So we are going to use quotient formula. Alright, and the formula is here. I'll tell you how to use this formula. Now the question can be asked in two ways. First, differentiate 2x plus 5 whole divided by 3x minus 2 with respect to x. Or it can be asked like this: if y is equal to 2x plus 5 whole divided by 3x minus 2, then find dy upon dx. So we are finding out dy upon dx. Now let me explain to you. See, the function is y is equal to 2x plus 5 whole divided by 3x minus 2. Okay. Now, we are differentiating both the sides with respect to x. You may write, I think one should write, on differentiating both sides with respect to x, we get. So, dy upon dx, d dx of y, d dx of y. Okay. Now this side, d dx of this, u upon v, the formula is here. See, look at the formula. V, you leave v and differentiate u, d dx of u. Then minus, now this time you leave u, don't differentiate, and differentiate d dx of v. Differentiate v. And whole divided by v square, that means denominator is square. You can remember like this also. Denominator into d dx of numerator minus numerator into d dx of denominator upon denominator square. Once again, please listen. D dx of numerator upon denominator is equal to denominator into d dx of numerator minus numerator into d dx of denominator upon denominator square. So you may remember like that, or you may remember like this: u upon v, v d dx of u minus u d dx of u upon v square. Now see, u upon v. So v, look at it. I've written all these steps. Things are very, very clear. Please listen to me. V, that means denominator, into d dx of numerator. That means u. Fine. Minus u. Alright? Minus u into d dx of v, v is 3x minus 2, d dx of v upon whole divided by v square. Once again, you see, denominator into d dx of numerator minus numerator into d dx of denominator upon denominator square. Fine. And the formula we are using, we are writing here. We should write down. The formula you can write down here. This formula we are using here. Okay. Now 3x minus 2 as it is, we have to differentiate 2x plus 5. So d dx of 2x plus d dx of 5. So d dx of 2x, 2 we keep outside, and d dx of x is 1. So that means ultimately you are getting 2, and plus d dx of 5 is 0. So total you are getting 2 only. Why? You know why? Because 2 into d dx of x is 1. Alright. So 2 into d dx of x, which is 1. So 2 into 1 is 2, and plus d dx of 5 is 0. So 2 plus 0 is 2. So finally you are getting 2. Okay. Minus 2x plus 5. 2x plus 5 as it is. Now you are differentiating this. d dx of 3x. 3 you keep outside. 3 is a constant, and it is with a variable. So the derivative will not be 0. The derivative of a constant is 0 when it is alone, like in this case here 2. In this case here 5. 5 is alone, so d dx of 5 is 0. 2 is alone, so d dx of 2 is 0. But here 3 is not alone, so 3 we keep aside. 3 into d dx of x, and d dx of x is 1. So 3 into 1 is 3, and minus 0, that means 3. So you are getting 3. Fine. Now open the bracket. 2 3s are 6x. Minus 2 2s are 4, minus 4. Minus c, outside the bracket we have minus sign, so minus 3 2s are 6x, so minus 6x, and minus into plus is minus, 5 3s are 15, so minus 15, whole divided by denominator 3x minus 2 whole square as it is. You need not open this. Now 6x minus 4 minus 6x minus 15, you can see minus 6x and plus 6x, they cancel each other. Minus 6x and plus 6x, right? Minus 6x and plus 6x, they cancel each other. Finally, we are left with minus 4 and minus 15, which is minus 19. Minus 19 whole divided by 3x minus 2 whole square, and that's the answer. This is the answer. I hope things are very, very clear. Alright? Okay. Now, next question, question number 2, a similar question I am giving you as homework. Answer also I am giving you. You please solve the question and see. That's the answer also I am giving you. So please write down question number 2, which will be your homework. Question number 2. Question number 2. Second question, your homework, and the question is x square minus 3 upon x plus 4. X square minus 3 upon x plus 4. Question number 2. Y is given. Y is equal to x minus 3. X square minus 3. X square minus 3 upon x plus 4. X square minus 3 upon x plus 4. Y is given. You have to find out dy upon dx. That is the question, to find dy upon dx. So therefore, to find dy upon dx, right? Your question is to find dy upon dx. This you have to find out. This is your question. If y is equal to x square minus 3 upon x plus 4, find dy upon dx. This is the question. Answer I am writing. Answer is x square plus 8x plus 3. X square plus 8x plus 3 dy upon dx is equal to x square plus 8x plus 3 upon x plus 4 whole square, upon x plus 4 whole square, upon this is your answer. Alright, this is your answer, and solve this question and see if you are getting the answer or not. Answer is given. Okay, this is the homework. Now question number 3, third question. u upon v, denominator into d dx of numerator minus numerator into d dx of denominator upon denominator square. Alright? Now question number 3. Third question. Third question. The third question is, y is given and y is equal to x upon x plus a, and then you have to prove, when expression is given, that we have to find out, show. So y is equal to x upon x plus a. Question number 3. Question number 3, y is equal to x upon x plus a. This is the question. Y is equal to given x upon x plus a, and we have to show, we have to prove that x dy upon dx, to show that x dy upon dx is equal to y 1 minus y and 1 minus y. This we have to show. Alright? This is our question. If y is equal to x upon x plus a, then show that x dy upon dx is equal to y 1 minus y. Okay. Now this we can do in two ways. One is we can apply that quotient formula. One is we can apply quotient formula u upon v, denominator into d dx of numerator minus numerator into d dx of denominator upon denominator square. That is method 1. That you please try. Method 2 is, see how I am doing in shortcut. Method 2. Method 1, you directly you differentiate this and then do the adjustment here and there. You'll get the result. Method 2 is, see, since y is equal to, it's given, y is equal to x upon x plus a, x upon y is equal to x upon x plus a. I am cross multiplying y into this. Alright. Therefore y into x plus a is equal to x. Alright, now I am differentiating both the sides with respect to x. Let's see what we are getting. So after this, please write down, on differentiating both the sides with respect to x, we get. And what are we getting? That you please look here. What are we getting? That you please look here. Or let me have this. Alright, we are differentiating this. Both sides. That means we are going to use UV formula. Yeah. You first function derivative of second plus second function derivative of first. Alright, so on differentiating, as I told you, please write down, on differentiating both the sides with respect to x, we get first function y. Alright, first function y into d dx of x plus a. Let me write down. Into d dx of x plus a, into d dx of x plus a, plus x plus a into d dx of y. That means dy upon dx. That means dy upon dx. And this side d dx of x. Alright. So d dx of x. Now see y as it is. You copy y as it is. And d dx of x is 1. D dx of a is 0 because 0 is because d dx of a is 0 because a is a constant. So 1 plus 0 means 1. That means simply y here. You are getting fine. Nothing. Y. Y into means y into 1 means y. Plus x plus a x plus c, and dy by dx we want dy upon dx, and d dx of x is 1. Now keep on seeing the result. What to get? You have to get x dy upon dx is equal to y 1 minus y. X dy upon dx is equal to y 1 minus y. 1 minus y. Oh, y if you transpose from left to right, you are getting 1 minus y. One by one you see the terms, the expressions, what you need, are you getting or not? What is the result? You keep on seeing the result in this method. This way, if you are doing a question, then you should keep on seeing the result. What to get and how much you got. So 1 minus y you want in the result. X dy upon dx is equal to y, 1 minus y. So let us transpose this y from left hand side to the right hand side because 1 minus y we are getting. We got it. So therefore x plus a and dy upon dx is equal to 1 minus y. Alright, we want x dy upon dx. We want x dy upon dx. So you can bring this x plus a down if you want. X plus a down you can bring. So you can write down therefore dy upon dx, dy upon dx is equal to 1 upon x plus a and into 1 minus y. What do you say? Fine? This x plus a we are taking down here. Now if you see the main question, in the main question y is given x upon x plus a. Y is given. Main question, if y is equal to x upon x plus a, isn't it? So if you have here x, then x upon x plus a you can write on y, and in the result on the right hand side you want y, you don't want x plus a and x etc. So if you multiply both the sides by x, which we can do because we are doing on both the sides, so if you multiply by x dy upon dx, and that also you want, x dy upon dx you want in the result. So let's multiply both the sides by x and let's see what we get. So then we get x dy upon dx. So we get x dy upon dx is equal to x upon x plus a. X upon x plus a and into in bracket 1 minus y. 1 minus y. Got it? 1 minus y. Now this is nothing but y because it's given in the question. This is given in the question. If you see the question, you can call that equation number 1. This is y. This is y. If you see the question. So here you can write down y. So then you get therefore x is equal to, this is y, and in bracket 1 minus y. And this is the result. This is the result which was to be shown. This was to be shown. Got it? This was to be shown. QED. Q, E, and D. This is the result. X dy upon dx, this was to be shown. That was the question. If y is this, then show that x dy upon dx is equal to y 1 minus y. I think things are very, very clear. Okay then. Thank you so much. Thanks.